In an endless quest to find answers to humanity's two biggest questions, scientists have now shifted their gaze from distant stars to our own solar system. Those two big questions are, where did we come from and are we alone in this universe? These are the questions that have compelled human civilization to think since the very beginning. After decades of struggle, finally, National Aeronautics and Space Administration has launched the most ambitious mission yet in the search for answers to these questions. Its target is Europa, one of Jupiter's 4 largest Galilean moons. From the beginning, scientists have believed that beneath Europa's surface lies a vast ocean, where beyond all our sight there could be a completely different world, a world where life might be thriving. Europa has always been a part of scientists' imaginations where life is flourishing. In reality, Europa is located in a very special place, where due to the tidal forces of Jupiter and its other moons, tidal pressure is created inside Europa, which leads to the generation of internal heat within Europa, and because of this heat, subsurface oceans have formed beneath Europa's surface, where hydrothermal vents create perfect conditions for life to develop. With the Europa Clipper spacecraft, we will finally be able to study this frozen world in detail and also search for basic elements of life such as organic compounds there. And this is also the mission of the Europa Clipper. It is National Aeronautics and Space Administration's largest interplanetary mission so far. This flagship project, built at a cost of about $5 billion United States dollars, was launched on October 14, 2024 by SpaceX's Falcon Heavy rocket. Once it reaches the Jupiter system by 2030, it will perform 49 flybys of Europa and will send us the most detailed images and observational data of Europa to date. Is this mission only about science, or is there something else as well? So what is it that makes Europa so special, and what can we expect from this mission? Why Europa after all? Europa is not just a moon. Rather, it is also a prime location selected by scientists to search for extraterrestrial life. This moon, which orbits Jupiter, completes one orbit every 3.5 Earth days. Because of the gas giant Jupiter and the large moons nearby, it must be getting a lot of power. And just like we see in the oceans on Earth, there too, beneath Europa's surface. Even without sunlight, life must be thriving there with the help of chemical energy and heat energy. It is estimated that the data from the mission on Europa revealed that there are large cracks in Europa's icy crust. From where the water inside it keeps getting released into space, creating huge geysers that reach several miles high. The chances of organic molecules being present in this water increase significantly because it is directly connected to the subsurface ocean beneath it. If organic compounds exist on Europa or even microbial life, it would completely change our understanding of biology. Wherever water is found on Earth, life is inevitably found as well, from the hottest deserts to the coldest glaciers. But does this definition of life apply to what's hidden on Europa? Its instruments will also measure Europa's gravity and magnetic field so that the depth of Europa's subsurface oceans and many mysteries related to it can be uncovered. There is no plume coming out of Europa's geysers. Rather, it's about understanding how that ocean interacts with Europa's cold crust and what processes are going on inside its warm core. During its 4-year mission, Clipper will provide us with the data that will give us evidence of Europa's habitability. With liquid water, heat, and potential organic molecules, Europa presents a very intriguing possibility that life could exist beyond Earth, hidden far from sunlight beneath a thick layer of ice. The Europa Clipper mission is the result of decades of scientific advocacy and continuous efforts. In fact, scientists have been urging National Aeronautics and Space Administration to send a mission to explore Europa since the early 2000s. But like other ambitious missions, this idea also faced many challenges, especially due to budget-related obstacles. Just a year before getting approval in 2014, National Aeronautics and Space Administration had clearly refused the government that they have no funding for the Europa mission. The very next year, the agency receives $100 million for this mission. To begin this work, Jet Propulsion Laboratory was assigned to build the spacecraft, considering its expertise in planetary exploration. And again, it will come back towards us, that is, towards Earth. In 2026, it will fly by Earth again, gain the necessary speed, and then head towards Jupiter. By 2030, this spacecraft will reach the Jupiter system. After reaching its destination, it will perform 49 flybys of Europa, and with each flyby, the spacecraft will get closer to Europa. This is how, in the past, the Galileo probe explored Europa. And that's when scientists got the first indications that this moon is much more than just ice. There could be an ocean beneath its surface, a discovery made at that time by scientists, just as they will do when they fly by Europa. It will collect data on the moon's magnetic field and gravity, which will help detect the presence of an ocean hidden beneath its surface. And besides this, we will also explore deep into this hidden ocean in space, where there might even be microbial life or organic compounds present. The Clipper mission will collect and analyze these water samples and will detect the presence of amino acids in them. Amino acids are also called the building blocks of life. If the Clipper mission succeeds in this, it will be the first evidence of life beyond Earth. The spacecraft will also study how Europa's oceans interact with its upper layer, which is the ice crust, and the lower layer, which is the heated mantle. The Clipper mission will use radio waves to penetrate the ice and map the surface beneath it, just like how an X-ray machine scans our body. During its 4-year mission, it will orbit Jupiter a total of 80 times, and each time it will provide us with new details about Jupiter and Europa. It will also provide information about its geology and potential habitability. With the help of this data, scientists will be able to create a model of how Europa's oceans function and whether they can sustain life. By the year 2034, when this mission reaches its final stage, it will be intentionally crashed onto Jupiter's other moon, Ganymede. However, considering the mission's cost and the spacecraft's condition, this mission can also be extended. With every flyby, this Clipper mission will bring us closer to finding the answer to that age-old question of ours. Are we alone in this universe? And with every discovery that follows, we will begin to understand the worlds that exist beyond Earth. The Europa Clipper mission is much more than just a scientific endeavor. It is a symbol of human curiosity and determination. For decades, scientists have advocated for this mission and struggled to bring it from an idea into the real world. This is a mission of hope that we are definitely going to find something on Europa. Even though it has now embarked on a long journey to Jupiter, this one mission carries the dreams of thousands of scientists. If Clipper succeeds, it will mark the beginning of a new era in space exploration. Preparations will also begin to send missions to other such worlds in our solar system and beyond, and even if by accident, if we even find a small sign of life, it will change human history forever. This search has just begun, but this mission is going to change the meaning of space exploration. Whenever we talk about mission to the sun, the first thing that comes to our mind is National Aeronautics and Space Administration. Parker Solar Probe is a National Aeronautics and Space Administration spacecraft that is literally staying in the sun's atmosphere and studying the sun. Apart from this, many missions have already been sent to the sun. For example, National Aeronautics and Space Administration and Germany together launched Helios 1 and Helios 2, which are called Parker Solar Probe. The Parker Solar Probe was sent to study the sun. It has become the most successful mission so far. But just 2 years after this, National Aeronautics and Space Administration, together with the European Space Agency, launched another mission to the sun on February 10, 2020. The name of this mission is the Solar Orbiter. This is also one of National Aeronautics and Space Administration's ambitious and major solar missions. After this, there are no other names on the list of missions sent to the sun, but India is now going to change this list. After Chandrayaan-3 made headlines, India is set for another milestone. According to the Indian Space Research Organization or Indian Space Research Organization, Chandrayaan-3 will work on the surface of the moon until around August 5. But before that, India is about to create another milestone. Yes, on September 2, India's first solar mission, Aditya L1, will be launched from the Satish Dhawan Space Center in Sriharikota. This day will also be recorded in the pages of India's history when Polar Satellite Launch Vehicle Extra Large will carry the Aditya L1 spacecraft upwards with a loud roar. This mission of India will be a state-of-the-art mission in itself. Although with this mission we won't be touching the sun or its atmosphere, we will definitely study the sun in a much better way while staying close to the Earth. First of all, immediately after launch, this spacecraft will be placed in low Earth orbit about 800 kilometers above the surface, and after that, this spacecraft will proceed further. Surya Namaskar unfolds its solar panels. As this is an Indian Space Research Organization mission, it's named Aditya, Sanskrit for sun. The full name of this mission is Aditya L1, which means Aditya Lagrange Point 1 mission. This means that this mission will not remain in lower Earth orbit. Instead, it will stay at Lagrange Point L1 about 1.5 million kilometers away from Earth and study the sun. Now, a question might come to your mind, why L1? Why not somewhere else? So you see, Lagrange Point is a really amazing thing. That's why, before understanding this mission, you need to understand the science of Lagrange points, and to understand this, we'll definitely take an example. Now, suppose that with a certain amount of gravitation, the sun is pulling things towards itself. On the other hand, we have our Earth, which also pulls things towards itself with a certain amount of gravitation. The sun is on one side and the Earth on the other, both pulling objects toward themselves. So, at a specific point in space, something will happen such that the force with which our Earth is pulling, the sun will also be applying the same force, and because of this, that object in space will not move anywhere. At that point, the gravitational forces from both sides will balance out and a neutral gravity point will be formed. These gravity neutral points are called Lagrange points, which were discovered by the great mathematician Joseph Louis Lagrange. When it comes to space missions, we can use these points as parking spaces for spacecraft. When we talk about placing a spacecraft in Earth's orbit, whenever any object or spacecraft is close to Earth, it constantly feels Earth's gravity. Earth constantly pulls it towards itself, so the spacecraft has to keep firing its engines repeatedly to correct its orbit and stay in orbit, because Earth keeps pulling it, causing its orbit to decrease. To correct this, we have to keep firing the engines continuously. This involves the cost of cryogenic fuel, and secondly, once the fuel runs out, the mission's life also ends. Many times it also happens that the satellites are completely fit, but because the fuel runs out, the entire mission comes to an end. So to deal with this problem, the spacecraft is placed at the Lagrange point, where the spacecraft does not experience any major gravity force, which reduces fuel consumption and significantly increases the mission's life. The best example of this is National Aeronautics and Space Administration's James Webb Space Telescope, which has been placed at Lagrange point L2. I hope by now the concept of Lagrange point is clear to you. Now pay attention to the Lagrange points in the Sun and Earth system. There are a total of 5 Lagrange points in this entire system. Out of these, L1, L2, and L3 are on a straight line connecting both masses, and all 3 of these Lagrange points are unstable. Meanwhile, L4 and L5 are on different sides. If you look closely at the L1 point, it is located close to the Earth. It's about 1.5 million kilometers away, and its most important feature is that from here, the view of the Sun is always available. Here, events like lunar or solar eclipses, and that's why L1 has also been added to its name. I hope this point is clear to you now. So Aditya, after entering Earth's lower orbit, the L1 spacecraft will gradually maneuver towards the Lagrange point L1, and it will take about 109 days to reach L1. Yes, 109 days, just like Chandrayaan-3 took 42 days to reach the moon. If you want to know why it takes so much time, you can watch our video here. After watching this video, all your concepts will be clear. Now our Aditya L1 has reached the Lagrange point after 109 days. Now after reaching there, it will be placed in a halo orbit. A halo orbit is an orbit where satellites remain more stable. And now Aditya L1 is ready to use its onboard instruments. So let's talk about the payloads of this mission. The spacecraft will carry 7 payloads on this mission, and the first among them is Visible Emission Line Coronagraph, which stands for Visible Emission Line Coronagraph, and this instrument is going to be the primary payload of this mission. We will definitely learn what a coronagraph is, but to understand why this payload is so important, we first need to go further. In January 2008, when the Aditya mission was being conceptualized, it means that the foundation of this mission is very deep. An advisory committee was formed for this mission, and it was decided that a small satellite weighing about 400 kilograms would be built. It would have a coronagraph installed, and by placing it in low Earth orbit, the Sun's corona would be studied. For this mission, an experimental budget of 30 million was also allocated in 2016-17. But after that, even more revisions were made to this mission, and its scope was also extended. Now it was presented as a dedicated solar and space environment observatory, and this mission was given a new direction. Now, instead of placing it in low Earth orbit, a plan was made to place it at the L1 point, and along with that, it was given a new name, Aditya L1. In 2019, 3.78 billion rupees were allocated for this. So, in this way, the mission that was initially meant only to study the solar corona has now become a complete solar observatory. But the amazing thing is that even today, the primary objective of this mission is still to deeply study the solar corona. That's why the instrument called Visible Emission Line Coronagraph is its primary payload. Visible Emission Line Coronagraph stands for Visible Emission Line Coronagraph. So what exactly is a coronagraph? Look, when we look directly at the sun, its brightness is so intense that we can't really see anything properly. It's just like the headlights of an oncoming vehicle on the road at night. When it shines into our eyes, we can't see what's in front of us anymore. The same thing happens in the case of the sun. So to avoid this, an attachment is added to the telescope. Just like we block the sun, meaning we block the direct sunlight coming from the sun, you can understand it as if we artificially create simulate a solar eclipse, and by doing this, we can see the sun's corona very clearly. So in this way, this telescope will be able to study the sun's atmosphere and corona. If we talk about its capability, it will be able to study the sun in visible and infrared wavelengths. What exactly goes on inside the sun's corona? What is the reason behind coronal mass ejections? Where do they originate from and why do they form? What is the link between field lines and the solar corona? Why is the corona so hot? And how do the changes on the sun affect space weather and the Earth? These are some of the questions that this instrument will try to answer. The second payload is the Solar Ultraviolet Imaging Telescope, or Solar Ultraviolet Imaging Telescope. This instrument will study the sun's atmosphere in the 200-400 nanometer wavelength range using 11 different filters. Until now, the sun has never been studied in this range before. The third payload is the Aditya Solar Wind Particle Experiment, or ASPEX. It will study the properties of the solar wind and the changes that occur in it. The fourth payload is PAPA, yes, the Plasma Analyzer Package for Aditya. It will study the composition of the solar wind and its energy distribution. The fifth payload is the Solar Low Energy X-ray Spectrometer, or Solar Axis. It will study the X-ray flares occurring in the solar corona and will try to find out whether the heating mechanism in the solar corona is due to X-rays, because X-rays contain high energy. The fourth payload is L1 Orbiting Spectrometer, which means High Energy L1 Orbiting X-ray Spectrometer. Its job will be to detect dynamic events occurring in the solar corona. How much energy does the solar corona contain? How much energy does it take to accelerate so many solar particles? And where does all this energy come from to carry out such an event, that is, for solar mass ejection? How does that energy get concentrated at that point? There are many such questions whose answers we can get from this instrument. The seventh and last instrument is the magnetometer. It will be used to study the direction, properties, nature, and magnitude of the magnetic field of celestial bodies. Overall, if we look at it, this is a big package through which we can get answers to almost every mystery related to the sun. Well, this is India's first mission to the sun, but humanity has set out towards the sun many times before this as well. National Aeronautics and Space Administration started solar probes in 1960 with the Pioneer 5 mission. This mission was successful, and after that, a whole series of Pioneer missions was sent. Among the old missions sent during that era, the most well-known ones include Helios A and B. The German and American space agencies conducted these missions together. After that, the core of the sun was investigated through the SOHO mission, a collaboration between European Space Agency and National Aeronautics and Space Administration, and it's been almost 27 years now. This mission is still ongoing. After that, several more missions were sent toward the sun, but in 2018, the Parker Solar Probe broke all previous records and became the spacecraft to get closest to the sun. This is truly an engineering marvel. It is specially studying the solar corona at close range. After that, in 2020, the European Space Agency launched the Solar Orbiter to study the sun's heliosphere. And now, on September 2nd, 2023, India is launching Aditya L1. This mission will continue to study the sun for about 5 years and 2 months. If we talk about the major science objectives of this mission, the main objective will be to study the dynamics of the sun's upper atmosphere. The upper atmosphere includes the chromosphere and the corona. Understanding the physics of chromospheric and coronal heating, solving the mystery of the origin of coronal mass ejection, and studying plasma particles to understand the sun's particle dynamics. This will help us understand their effects on Earth and keep ourselves safe in outer space. By studying coronal loops, their origin, temperature, and properties will also be studied. The sun will be studied in multiple layers, and efforts will also be made to understand the processes happening inside it. Many mysteries have formed around the sun's magnetic field, so the magnetic field will also be studied in detail. And finally, data will also be collected on space weather, its dynamics, and how it affects our Earth. The sun drives our entire solar system and is the biggest source of energy on Earth, and all life that thrives here is completely dependent on the sun. If the Earth gives birth to life and nurtures it, then the sun fills that life with energy. That's why it's very important to have knowledge about the sun. As an Indian, this mission will definitely make us proud and will inspire our generations to be curious about space. But in the true sense, this mission is for all of humanity. Because the sun drives this entire Earth, it gives life to all of humanity and the whole world. So that there are no secrets left between us and the sun, all of humanity will always remember this mission of Bharat. The Voyager, a messenger sent by humanity into the infinite universe, is now moving toward its end. This spacecraft has traveled about 235 billion kilometers from Earth and is now about to shut down due to its dying battery. The nuclear-powered batteries inside it have also stopped working now. Because of this, it is becoming increasingly difficult to maintain contact with Earth. According to National Aeronautics and Space Administration scientists' estimations, it will last until a maximum of 2035, but this time span will become even shorter if its scientific data collection operations continue. That's why recently National Aeronautics and Space Administration has also shut down its data bringback, and now it's almost in standby mode. National Aeronautics and Space Administration has also ended its active connection with them. Currently, they remain in a passive state while the Deep Space Network maintains routine connections. Recently, when the connection was re-established with the Voyager probe, the mysterious signals received from it surprised the scientists. However, that's a different topic. To get more detailed information about that, you can watch the video appearing in the I button. Anyway, these spacecraft, after traveling billions of miles over 45 years, are now depleted. With their energy fading day by day, they are on the verge of shutting down. In such a situation, it wouldn't be wrong to say that the Voyager mission is heading toward its end. Although we all knew for a long time that this moment had to come someday, as they say, just the thought of the end brings fear. In the same way, our warriors are moving towards such an end, but it's an end that will be extremely lonely and shrouded in darkness. Even after this ends, the journey will continue moving forward, and this karma will keep moving forward until a destructive asteroid comes in its path. Well, only time will tell how far this messenger of humanity will go in the universe. And maybe even after time has passed, we still won't know what condition our space probes are currently in. That means in the end, they will die an anonymous death. But as they say, some things become immortal even after dying. In this case too, the achievements and accomplishments of Voyagers will not let them die. The contribution it has made to science and astronomy will make it immortal forever, and anyway, the golden record present in it will keep it alive forever even after it is gone. They are designed to preserve humanity's message within themselves even after massive destruction or being shattered. So even if these spacecraft are lost for thousands or millions of years, any alien civilization that finds them will receive this message from humanity and Earth. We did it right. At the very least, they will know about us and get the answer. In this infinite universe, they are not alone. Others exist who are alive, can think, and thanks to science, can explore the endless cosmos. The Voyager mission is special in itself, in fact, extremely special, because it goes far beyond any ordinary scientific mission and is connected to human emotions. These missions not only introduced us to our solar system, but also made us aware of some of the deep mysteries hidden within it. These spacecraft are also one of a kind because they traveled such a long distance for the first time and are still continuing their journey today. Currently, Voyager 1 is the farthest man-made object from Earth, followed by Voyager 2, which is the second farthest object from Earth. Over time, National Aeronautics and Space Administration has taken several major steps to conserve the decaying power in the Voyager spacecraft. The most significant step among them is shutting down various scientific instruments. At launch, both spacecraft had 10 scientific instruments working. Now, they have only 5 and 4 respectively. The creation of the Voyager spacecraft is interesting, especially since National Aeronautics and Space Administration originally had no plans to launch such a spacecraft. In the mid-60s, when discussions were going on about interplanetary flyby missions, initially there was a unique mission called MJSN Mariner. The 1977 plan was to study Jupiter and Saturn, aiming to closely examine both gas giants. But the story took a twist when an amateur scientist working at National Aeronautics and and Space Administration Jet Propulsion Laboratory discovered an amazing opportunity for space exploration. Actually, this was a unique planetary alignment of all the gas giants, due to which all the planets were about to come in a straight line. In such a situation, if a spacecraft could be sent to even one of these planets, it wouldn't need much fuel to reach the others. The slingshot force gained from the cross orbits of these planets would help our spacecraft reach its destination. Seeing this opportunity, National Aeronautics and Space Administration's ambitions grew even bigger, and now National Aeronautics and Space Administration plan to do something grand. Actually, not just one or two, but all 4 outer planets were on National Aeronautics and Space Administration's radar. From gigantic Jupiter to icy Neptune, studying every gas giant was on National Aeronautics and Space Administration's agenda this time. Primarily, this mission was planned for the first 12 years, but in 1989, right after the flyby of Neptune, it entered a new chapter, where it was moving beyond the search for mysteries to making history. A milestone was achieved when Voyager 1 spacecraft crossed the heliopause and entered interstellar space, and a few years later, its companion Voyager 2 also reached the same milestone. If we talk about the next destination or achievement of these 2 spacecraft, currently both spacecraft are moving forward in deep, wide space, where there is nothing except darkness and freezing cold. Besides the onboard thrusters on these spacecraft, a constant forward force pushes them back. In fact, after the power pack launched from Earth, their speed increased greatly in outer space. Jupiter's gravity helped increase it even more. The slingshot force did. As a result, they are still moving forward at high speed even today. Apart from this one factor, there are many other external reasons due to which these spacecraft launched years ago are able to maintain their speed. National Aeronautics and Space Administration scientists say the radioisotope thermoelectric generator has become inefficient due to age. The radioactive substance present in the nuclear batteries is naturally decaying, causing the power to drop at a rate of 4 watts per year. As a result, there are chances that it will eventually run out of power by 2030. Apart from this, let's talk about the future encounters of the Voyager spacecraft. If we assume that these spacecraft remain unaffected and untouched by any external factors for the next 300,000 years, then they'll reach their next destination. Voyager 1 will arrive at the AC plus 79 3888 star system in 40,000 years, while Voyager 2 will reach Sagittarius A in about 298,000 years. And hopefully, until then, they will remain safe from troubles and obstacles and carry the message of humans to those unknown extraterrestrials. By the way, what do you think about this? Will they be able to safely reach these stars, or will their journey end before that? 40,000 years later, in the faint light of an unknown star, a piece of ancient metal floats in the cold, dark expanse of interstellar space. This is Voyager 1, which human civilization sent in 1977. Suddenly, an unknown civilization has spotted this spacecraft. Their eyes fall on a shiny gold-plated golden record which contains the sounds, music, and many images from Earth. They touch it, and in an instant, the voices of the millions of years old human civilization echo before them. But will they be able to understand it? And will this message really be able to tell our story? This scene leads us to a question. In 1977, when Voyager 1 and Voyager 2 bid farewell to our solar system with the golden record, they carried a time capsule of our world with them. But if we launch Voyager 3 today, will we send another golden record like that again? Or will the technology of our digital age help us do something else, something more complex, something bolder? How will we tell our story to those distant civilizations in the infinite darkness of interstellar space, and will there really be anyone out there to listen to our story? In 1977, when Voyager 1 and Voyager 2 left Earth, they were not just machines, they were messengers of humanity. They were sent to explore the outer planets of the solar system: Jupiter, Saturn, Uranus, and Neptune. A rare planetary alignment gave them the opportunity to hop from one planet to another using gravity assist. Voyager 1 visited Saturn's moon Titan and then left the solar system, heading out into interstellar space. Voyager 1 visited Saturn and then left the solar system, heading out into interstellar space. sounds of nature, music, greetings in 55 languages, and messages from American President Carter and United Nations Secretary General Waldheim were also included. It was a phonograph record made of gold-plated copper, and it came with a stylus. It was meant to be played at 16 2/3 revolutions per minute. Sounds of nature, music, greetings in different languages, and messages from American President Carter and the United Nations Secretary General were inscribed on it. But the golden record itself was a complete story of Earth, of our humanity, and of our hopes. It was placed in an aluminum cover which had a layer of uranium-238 on it. Uranium was used for two reasons. It is 5 times more effective than lead at blocking cosmic rays and X-rays, and its decay can help tell the age of the record to any unknown civilization. The golden record wasn't just a scientific experiment, it was a bold step, it was a risk. Should we give our information to unknown civilizations? Some believed it could be dangerous, but the Voyager spacecraft is moving so slowly, at about 56,000 to 61,000 kilometers per hour, it would take them 77,000 to 84,000 years just to reach our nearest star, Proxima Centauri, and they're not even heading toward Proxima Centauri. First, they would have to cross the Oort cloud, which is the outer shell of the solar system, and it would take them about 20,000 years just to get through that. That's such a long time that it's beyond our imagination. 20,000 years ago, humans were in the Stone Age, and today, in the era of the digital revolution, our technology has brought us so far. If we last another 20,000 years, we could become a spacefaring civilization. But the question remains, if we send Voyager 3 today, will we send something like the golden record again, or will our technology show us a different path? Will our message still be that simple, or will we want to throw something more complex into the cosmic ocean? The golden records of Voyager 1 and Voyager 2 are among the most daring attempts of human civilization. Even though we sent them off fully protected, will these records really last forever, or will the cruel forces of the cosmic ocean silence them for good? As far as interstellar space is concerned, it's not empty at all. It's a place where interstellar dust exists. Its particles are even smaller than a micrometer. They collide with Voyager at speeds of about 50,000 to 70,000 kilometers per hour. Each collision creates a tiny crater which can slowly damage the surface of these spacecraft and possibly even the golden records. These particles are so small that their size is about 1,000th of a millimeter, but their speed makes them deadly. In addition, there are charged particles from the solar wind and cosmic rays coming from supernovae or black holes. They can dislodge atoms from the golden record's crystal structure. Over millions and billions of years, these processes can weaken the records. National Aeronautics and Space Administration had already understood this risk. That's why the golden records are kept in an aluminum cover. It has a coating of uranium-238 which will protect it from the harsh environment of interstellar space. An infographic is also made on this cover which explains how to play the record. But the question is, how will an unknown civilization which might be using completely different technology be able to understand it? The golden record is based on 1970s technology, analog waveforms with images and sounds containing 512 vertical lines. It was a marvel of its time, but today it seems outdated. Scientists like Nick Obag at the Captain Astronomical Institute have calculated how the different trajectories of the Voyager spacecraft will affect their golden records. Voyager 2 is heading toward a red dwarf star called Ross 248, which is about 17 light years away, and it will take more than 30,000 years to reach there. However, it will encounter less interstellar dust. But Voyager 1, which will pass through denser dust clouds in the galaxy, may have its cover wear out more and faster, which will also increase the risk of damage to the records. But even then, scientists estimate that these records could last for about 5 billion years. By then, the Milky Way and Andromeda galaxies will collide. What will happen to the Voyagers during this event? Ober's models suggest that there is a 20% chance that the Voyagers will be thrown out of the new galaxy during this time, into intergalactic space where high-energy cosmic rays will become even more dangerous. Will the Golden Record survive this? And if we send Voyagers 3, will we rely on such analog technology again, or will our modern technology show us a new way? The Golden Record dared to carry the story of humanity into interstellar space in the 1970s. It was a phonographic record made with the most reliable technology of that time. But today, we are living in an era of digital revolution. If we launch Voyager 3, will we rely again on such analog technology, or will our modern technology show us a more powerful, more complex, and riskier path? In today's world, data storage means terabytes, petabytes, and nanoscale technology. Fused quartz disks, which are written with femtosecond lasers, could be a revolutionary option for Voyager 3. A 12cm quartz disk can store 360 terabytes of data. That's millions of times more than the Golden Record, and this disk can last for 14 billion years, which is even longer than the lifespan of our sun. The Golden Record included 115 images, music, and greetings in 55 languages. But on a quartz disk, we can store entire books, videos, scientific data, and maybe even a summary of the whole internet. But this is where a mysterious challenge arises. Data is written onto a fused quartz disk at the nanometer scale in 2 optical dimensions and 3 spatial dimensions. To read that data, a technique is required that perhaps only an advanced civilization might possess. On the other hand, the simplicity of the Golden Records was its strength. Anyone could play it with a stylus and some instructions. But to read the quartz disk, you would need laser technology and nanoscale decoding. Are we ready to take the risk that some unknown civilization might not be able to understand our complex technology? There's another question. If we send an electronic reader with Voyager 3, will it be able to withstand the harsh conditions of interstellar space? Cosmic rays, interstellar dust, and charged particles can destroy any electronic devices over millions of years. Although the fused quartz disk could last 14 billion years, the equipment to read it may become obsolete in a few thousand years. Then our message, no matter how detailed it is, will be lost in silence forever. The strength of the Golden Records was their simplicity. They were like a vinyl record that anyone could understand without complex technology. But today, our digital world gives us the opportunity to send more data, more stories, and more complex messages. But the question is, will we choose quantity or simplicity? Will we choose for our message to reach every civilization or only the most advanced civilizations? And if we send Voyager 3, will our message become a shining star in the cosmic ocean, visible to everyone, or will it just remain as silent debris? Voyager 1 and Voyager 2's Golden Records boldly sent humanity's story into interstellar space. It was an attempt filled with hope and curiosity. But if we launch Voyager 3 today, would we dare to send a similar message again? But this time, the question is even bigger. Should we reveal our existence to the universe? Some people had warned while making the Golden Records. Should we give unknown civilizations our information, like our location, our culture, and our weaknesses? Could a hostile alien civilization misuse this information? Today, this question is even more serious. Voyager is much slower than the speed and flight. It will take more than 20,000 years just to cross the outer shell of our solar system, that is, the Oort cloud. This means that if any civilization finds these spacecraft within our lifetime, then maybe they are already present in our solar system. But this risk is not limited to just hostile aliens. If we send a new message with Voyager 3, like the fused quartz disk, which can store 360 terabytes of data. So if it somehow falls into the wrong hands, what will be the consequences? Today, in our digital ecosystem, data brokers, personalized ads, and online tracking have turned our personal information into a business. Our email, name, address, age, and profession, such information is sold just to exploit us. If this is a security threat even on our own planet, then how dangerous it could be to send the entire story of our human civilization into interstellar space is just as deep a moral question. Do we have the right to decide that the story of our civilization should be sent into the universe? If we send our entire digital history with Voyager 3, our wars, our mistakes, our achievements, if we send all this, are we unknowingly exposing our weaknesses, or is it our responsibility to leave our voice in the cosmic ocean? To show that we existed, we dreamed, and we tried. Will the message of Voyager 3 be our hope, or will it become our greatest mistake? Voyager 1 and Voyager 2 have sent a time capsule in the form of golden records, which could reach an unknown civilization millions or perhaps billions of years from now. But if we launch Voyager 3 today, would we choose such simplicity again, or would we opt for the powerful technology of the digital age? Billions of years from now, when the Milky Way and Andromeda collide, the Voyagers or their golden records could still drift in the cosmic ocean. Interstellar dust and cosmic rays might have worn them down, but they would still be protected by uranium-238. Those records, carrying the last traces of human civilization, would be drifting somewhere, waiting for someone. If some civilization finds them, they will hear our laughter, our lives, our music, and our dreams. They will know that a small planet, a tiny blue dot, once wanted to reach the stars. But what will Voyager 3's message be? As Carl Sagan said, our message should be very simple so that every civilization can understand our story. Or will we rely on techniques like nanoscale, knowing that perhaps only the most advanced civilizations will be able to read it? And will we take the risk that our location and our vulnerabilities might reach a dangerous civilization? This is a puzzle that forces us to think about how to define our place in the universe. This story is not just about the Voyagers, it's our story. It's the story of the curiosity that gave us the courage to look beyond the Oort cloud to stars like Ross 248 and maybe even into intergalactic space. Friends, if you are also excited about this cosmic journey, you can support us by becoming a member of our channel so that we can continue to bring you more content like this. Friends, how did you like this video? If you like this video, make sure to like it and share it with your friends. For more videos like this, subscribe to the channel and turn on the bell notification. Friends, we'll see you soon with another video. Until then, stay curious, be happy, and goodbye.